Graphing gives you a good understanding of how vectors add and subtract because you get a physical feeling for what's going on. However, it's much more accurate to do analytical addition, subtraction, and in addition, there are other operations we want to look at, multiplication operations. So to do this, to do the analytical part, we introduce what's called a unit vector. And unit vector is a vector of length 1, kind of like a pound is a unit of force, a meter is a unit of distance, and so on. It's going to be universal, however, and represent any of those things. Notice I've drawn the three-dimensional space here, and we will be using three-dimensional space later on in the year. But we have an XY plane is in blue, the YZ plane is in pink, and Z comes out of the page. Y goes up, Z comes out of the page and into the page, plus Z and minus Z. So we're going to let I represent the X direction, okay, and you see it here. Minus I is the minus X direction. And notice the symbol there. Let me see if I can emphasize this. We've got I, and it has that little caret on top of it, so it'll be I, J. Let's try that again. I have I, has a little symbol above it. That's how we indicate a unit vector. We use, in print text and stuff, use bold to indicate a unit vector, but to do this by writing, we indicate that little hat, little caret above the left. That's a unit vector. A regular vector would be A with just a straight line above it like that. All right. K, J is the positive Y, minus J would be the negative Y. K is coming out of the page, represents the Z direction, and minus K is the minus Z direction. So, how do we do it? Well, 2I is simply a vector 2 units long. Now, it might be 2 pounds in the X direction. It might be 2 meters in the X direction. It might be 2 meters per second in the X direction. Whatever the quantity is, that's what it represents. Minus 3J is a vector 3 units long in the negative Y direction. And here we go, 2 dimensions. The vector 4I plus 3J is a vector in the positive X direction, 4 units in the X direction, and then 3 units in the positive Y direction. Notice that we're adding 2 vectors here, 4I plus 3J, just like you saw. This is a right triangle now. And so that's essentially what we're doing here. And what physically may be happening is it could be 4 pounds of force in the X direction simultaneously with 3 pounds of force in the Y direction, and you can calculate what the hypotenuse would be. That would be the actual length of the vector, and we'll look at that in a few minutes. But that's how we represent it. Now, the advantage of writing vectors like this is that they can be used directly in equations, which is interesting. Whereas if I said this is 5 pounds at 37 degrees, you can't plug that into an equation directly. This you can. And it depends on the operations that are involved, but we'll see how that works. So finally, we'll look at a 3-dimensional vector. Minus 8I, so that's minus 8 units in the X direction. Positive 5J, 5 units in the Y direction. And then positive 2K, that's 2 units coming out of the page in the K direction. So we have a vector. It's a little bit hard to show that. That's represented in this octant here of this dimension here. Wait, okay. So that's located in that octant there. So how do we generate these vectors? Well, as you saw, it was a right triangle. So if we have 185 pounds at 38 degrees, we want to break it into a base and a height, essentially. And I is the base, J represents the height. So you could probably do this on your own, take a look at that quickly before we go through it. Could hit pause if you want. And there's just sines and cosines. So that the cosine of 38 degrees is the adjacent over the hypotenuse, or 185 times the cosine of 38 gives you the adjacent side, which is I. Likewise, the sine is the opposite over the hypotenuse. So we get 185 sine 38j as a j. And so you get 146i plus 114j. And so it's just sines and cosines. We're just looking at 2 dimensions here for now. Try this one. 47 pounds at 150 degrees. A little trickier. The I direction is in the negative x direction. So try that out. Hit pause and figure out what you get, and then we'll look at the results. So let's see what the results are for this. Well, if you use the 150 degrees, the calculator will know that 150 degrees is in the second quadrant. So if you write 47 cosine 150, it automatically makes the result negative 40.7. If you choose to use the 30 degrees, which is fine, you have to realize that you're in the second quadrant and you have to make it negative manually. So I have this image drawn at another place, but in the first quadrant, both x and y are positive. In the second quadrant, x is negative, y is positive. Let me try that again here. So in the first quadrant, x is positive, y is positive. In the second quadrant, x is negative, y is positive. In the third quadrant, they're both negative. And in the fourth quadrant, x is positive and y is negative. So yeah, the calculator, if you put 220 degrees, it'll know you're in the third quadrant and it will give you both negative signs. So there's an advantage to using the overall angle. However, a lot of times that's not convenient and we can just use the angle given there, but you have to be aware of which quadrant it's in. Anyway, you get B is minus 40.7 and plus 23.5 J. So here are the rules of addition and subtraction. Only, very easy, only like vectors, unit vectors combine. So we can only add the i's, we can only add the j's, and we can only add the k's. So in the simple example given here, 6.2i will add to 2.1, and 3 minus 5.6 gives us this. So it's fairly straightforward addition. Now, once we have our answer, okay, we want to maybe convert back. Not always. This answer would be usable in an equation, but sometimes we do want to convert back. And how do we do that? What's the length of the vector? Well, it's just, as you see, it's just a right triangle. So all we need is the hypotenuse. And a lot of times it's good to sketch the what you see. Now we know it's 8.3i minus 2.6j. So we want to write, and it doesn't have to be exact, something that's about 8.3 units long, 2.6 is much shorter, it's negative. Notice how we combine them like we're adding vectors tip to tail. And this is just approximate, and it tells us that this is in the fourth quadrant, which there it is, positive x, negative y. You could tell that way too. This will give us an idea of when we get the angle, what that's going to be. So using the Pythagorean theorem, we square the I value, we square the j value, make sure the negative sign is inside the parentheses before you square it, and you get 8.7 units long. All right, Pythagorean theorem. What's the angle? Well, we use the inverse tangent of the j over I value. Minus 2.6 is the j value, 8.3 positive. So the minus sign is important because it gives us a negative 17.4 degrees. So we saw that the angle pointed down like this. So remember, negative angles are clockwise, and so that's the 17 degrees. The reference angle is reference from the x direction, and so there is a negative. So you could also write it as a positive 340 some odd degrees in that direction. Either one would be fine. Now, what if we wanted to add the two vectors we did, A and B? Well, you do that. Notice it's a good idea to sketch the vectors and add them graphically, and this is why we went through that, to see where it comes out. Now, we can see from this that A and B are going to be in the first quadrant. Sometimes it's good to visualize it. You can do this if you want. The sign of the vectors will always give you the sign of the I, and the sign of the J will tell you which quadrant it's in. But it's a good idea to sometimes do a sketch. And it doesn't have to be to scale. We know that A is 146 units in the x direction and 114 units up. That may not be very good to scale. They're probably a little closer in length. But that gives us the A, and the B is a minus 40, right? Minus 40 plus 23. And so we can see how we can sketch those vectors like that. We want to add A and B, so you do that, and then you'll get the result, okay? And then subtract B from A and do the same thing. And then your job is to not just find those answers, but also find out the magnitude and direction of both of those results. And I'll post solutions up a little bit later.